it will go into your records and so forth, properly submitted for accountability. Now it's my pleasure to introduce Stephen Scarbrough. He'll be talking to you today on a great subject, practical intelligence for cyber operations. And without further ado, Stephen, the show's yours.
Thank you. Can everybody hear me? All right. I feel like I'm like stuck over in the corner here away from everybody. So if you can't hear me, I move away from the thing a little bit more. Here we go. What if I do like this? There we go. Awesome. Here we are. All right. So good morning. I'm glad everybody came out. I'm a little tired. I'm not going to lie. So if I seem a little slow, I've been at DEF CON all week, and it's been busy and crazy there. So I appreciate everybody coming out this morning. We're going to have a really good conversation. I want it to be a conversation because this is a hot topic for everybody, right? Everybody's super interested in artificial intelligence, especially in this area, cyber operations. So we're going to try and talk about as much as we possibly can in the next hour or so. I do like questions. Throw me hard questions as much as possible. So we're really quick, what is AI? How is it used in cyber warfare in the different realms, both in defensive and offensive? What we're kind of seeing in our lab and some of the other customers and people we're working with in the industry. Challenges facing AI, and then we'll also talk about some social ethics and economic impacts of AI and cyber warfare and some of those other pieces to it as well. That's my beautiful face, as if you're not going to get to see enough of it in the next hour. If you see me walking around over the next few days and you want to stop and talk to me about it, I am not short on wind when it comes to the topic. I do like talking about it. We have a lot of good things, and I know a lot of folks in the industry, in the area. If you're interested in talking to somebody at NVIDIA as well, I'll get NVIDIA folks to come over and talk to you about their hardware and their piece, and we'll touch a little bit about it today. On my background, I am the Chief Technologist for IntelliGenesis Rapid Innovation Lab, IG Labs. We focus primarily on non-enterprise cybersecurity, so ICS, SCADA, those types of things, enabling those pieces, and then artificial intelligence. We have a deep learning pod in our lab, and we are doing some pretty cool stuff with it. And working directly with NVIDIA and their NVIDIA developers and hardware development teams, bring those pieces in and be able to do that really quickly. I think in the Columbia, Maryland area, we're the only small company that has a DGX A100 on-prem. They can do a lot of cool stuff. So if you want to see something, I'll show you afterwards. I have a red team and blue team background. I was in the Navy for 20 years. I was a CTN when I retired. Primarily NSA red team, blue team, SIG development, doing data analytics after I retired. When big data analytics and data science was first coming about 13, 14 years ago, when we really started pushing into it. What we didn't know at the time was really like the nascent days of what is becoming artificial intelligence, right? As far as big data analytics and stuff like that. That's why I'm a recovering data scientist. Anybody else a recovering data scientist? No? Oh, all right. So what is artificial intelligence? Oh, one in the back. That means I'm an AI technician now. AI developer, and that is very broad too. That leads right into this question. What is artificial intelligence? Anybody have a really good definition for artificial intelligence? There's a ton of them out there, right? Depending on who you're talking to, depending on what field you're in, if you talk to management, their idea of what artificial intelligence is very different than what somebody in the actual field is doing, right? And then even within the field, when we talk about artificial intelligence, we're talking a very broad swath of types of artificial intelligence techniques to get to AI. I think for like management, when we mainly go and talk to them or you hear them talk about it, they're talking about automation. Artificial intelligence to automate workflows and get things done, right? In this case, very low level, right? It's the ability for machines to mimic the human intelligence as closely as possible. And that sends shivers up a lot of people's spines when you say that. Machines mimicking human intelligence. Right? We're still a ways off from them being autonomous by themselves, being able to replace human beings. That's like the biggest fear you hear in the community nowadays is they're being replaced by artificial intelligence. In the lab, we like to talk about not replacing individuals with artificial intelligence, but augmenting their capabilities with it. And that's really where the discussion should be at, is how we take and or do this. Now, I'm not delusional. It's sometime in the near future. And when I say near future, the rapid development of this technology we're seeing accelerate faster and faster and faster. And when we get to quantum computing, right, that's when it's really going to take off even more. And I'm not just throwing about the quantum computing tag as like a thing. We see here a lot of people talking about quantum computing, and they're really doing just some quantum-ish type things, right? But it's going to get to the point where we'll have those things, and we should very much be worried and concerned about it, especially in the cyber operations area, just because of the way that some of the things they're going to be able to do, right? What they really are helping us do is like critical decision making, augmenting our processes, augmenting our personnel, and again, specifically for cyber operations, augmenting the capabilities of operators to be able to do their missions faster and better, right? To be able to give them those capabilities, to be able to harness the power of those machines and the intelligence we're teaching them to be able to do some of those things. In the lab, we're working on things like fine-tuning, we're going to talk a little bit more, fine-tuning large language models for defensive operations, taking and scraping cyber threat intelligence, training it specifically on that, giving it to operators to be able to ask it questions. So we can take junior personnel, put them in a SOC someplace or put them on mission, and they have a large language model or a chat GPT-like platform that they can augment their knowledge and their capabilities to help rapidly get them to where they need to be at and help clear away some of the false flags and some of the over flagging, over alert fatigue that they're getting, right? And to excel at repetitive tasks. Sometimes this is thought of like automation, but if you think about it, how many times a day does, say, a SOC operator have to go and inspect a packet? Go and inspect a report, go and look at flags, go and look at alerts, go and look at something, right? Those things are constant. So if we can take those things and teach the machine to do it, then we can clear some of those pieces away, help prioritize some of their workflow, and get them to be able to do what they need to do when they need to do it, right? And any junior SOC operators in here? None? Okay, we can make fun of them all day long. So most of the time when you get into a SOC, right, you're sitting there, you're on Splunk, you're on some sort of SIEM or something else. If you want to look up something, where do they go to? They're going to go to Google, right? Go to Google, they put in, hey, what does this flag mean or what this is? And they get back what? Thousands of results that they have to now weed through. Anybody like me, a Stack Overflow junkie? Now imagine if after 30 years of doing this, I still get lost in Stack Overflow. New folks coming out and getting in there, they get just as lost, right? So if we can pull some of that out, train that in large language model to get them to be able to weed out some of those things, focus their questions, focus their answers back, get them to do some other pieces, it'll help them, right? Inside of artificial intelligence, we kind of talking about it as this panacea thing. We say artificial intelligence, but there's really multiple layers within it, right? How do we train the artificial intelligence to be able to do that? And we do that through machine learning and deep learning. Now, artificial intelligence itself, augmenting humans, helping to do things, autonomous driving vehicles, large language models like ChatGPT, Bard, those types of pieces. Machine learning is how we go about getting it to do upper level, I will say, training those models to be able to do those things we want the AI to do for us, right? In this case, it's more advanced big data analytics. So some people, right, we're moving away from just doing statistical analysis and being able to train the machines to be able to identify some pieces for us. When we really get into the deep learning side, that's when we start talking about like the large language model development, looking at unstructured data like imagery, language models, and those types of things that are not necessarily going to be well structured, that we need to repetitively train it and have repeatedly gone through and refined that model over and over and over and over again, right? In machine learning, we're going to continuously monitor and everything else, but in deep learning, we have to build that piece out even more. Anybody ever remember seeing that, my example I like to use, the IBM commercial where they were talking about taking pictures of snow leopards on the side of the mountain, right? They talk about it like, made it sound like it's super easy, like IBM helps us identify snow leopards. What they don't talk about is the millions upon millions of photos that it took to be able to get to that point, and the thousands of hours it took to be able to train the model to be able to do that. And then the continuously training and refining of that model to be able to add more to it, right? To be able to do it. To start with that, you might start with like a stick figure of a cat and has to identify that, and you continuously build on features and everything else into it to get to a point. Same thing right now with large language models. That still falls within the deep learning area. We have to continuously give it new pieces. Anybody have any ideas of how large the feature set is for ChatGPT's OpenAI? We'll just say the newest one. I think they're up to about 170 billion right now. Yeah. We have, no, 170 billion, right? Now, it takes weeks to be able to retrain that, depending on the size of your deep learning environment. They have tens of thousands of GPUs that they're training it on, right? To be able to go through those things. In my lab, we have a DGX A100, which has 80 gig A100 cards in it. We're training our large language model on about 30 billion parameters, right? And it takes us right now about 4 to 5 days to be able to do it. If we dumb down those, and when I say dumb it down, if we reduce those, we can accelerate it out to a few hours, right? Depending on the size of it, right? But it takes a lot. It takes a lot of power, space, and cooling to do that. So, those pieces. AI and the cyber realm, right? We're focused on defensive and offensive. We'll talk about defensive first, on where we see it kind of going in. I don't know why it said, oh, there we go, AI-powered. AI-empowered intrusion detection systems. Now, I will not poke fun at any particular company or any particular people, but everybody in here knows that there are literally thousands upon thousands of companies out there right now trying to harness AI, right? And there are varying different degrees of what that looks like. We have some of our partners in Maryland that say, hey, we've got this new AI-enabled tool, and when we dig into it, it's doing an API called a ChatGPT. Technically, yeah, kind of, but not always. There's a lot of things going on in the field. Like one of our teams is even working on this, is like, how do we do, network monitoring, anomaly detection with artificial intelligence? The first thing will probably most likely be intrusion detection systems. How do we take and go from a flag-based, alert-based system, right, that we have to write a rule to be able to train artificial intelligence to realize something anomalous is happening on the network, right? Anybody following along at NVIDIA? Besides making a ton of money, right? Has anybody heard of Morpheus, the Morpheus cybersecurity framework, right? That is a pretty cool. We started working with them about a year ago on that, feeding in some pieces to us, getting it to us, and they have a really cool platform, because what we figured out is, and what they're figuring out is instead of doing, say, phishing detection, we can start modeling individuals within the network. And when I say individuals, we're not talking about just humans, and we're talking about the devices as well. So we can take devices, humans, groups of devices, and create individual models and be able to put that into the pipeline and be able to detect anomalous activity outside of that. Now, how long does that take an organization of 10 people to be able to baseline a network on that, create an AI-enabled IDS system? Not very long, 10 people. Now you look at an organization like the Army. How do I create a model for every person in the Army? It becomes a very time-consuming thing. A lot of work goes into it. Maintaining that model through the life of inception of a soldier, from the time they enter and get that first email address and get access to a computer for the first time. The Department of Army civilians, contractors, everybody else that's constantly in and around that. right? So building those pieces out becomes very huge, and that's what will go into those intrusion detection systems so they can be able to see those things. Also, the data volumes that it takes. Again, I don't like to poo-poo on anything, but big data platform, BDP, anybody a fan? Big data platforms, where we're getting it at, constant ingest of new data that's coming in from all over the place, new platforms that we're developing, generating new information, new weapon systems coming on, generating new information, tons of data. One of the examples we're going to talk about is in adversarial AI is poisoning the data, right? That's a big problem. But these intrusion detection systems will become more advanced, again, beyond just alerts and signature-based intrusions. It'll be activity, heuristics, and beyond that. Malware analysis. Any malware analysts in the audience? Man, I thought I was going to get somebody. So this is something we see a lot coming out now too, is how do we do malware analysis with large language models and things like ChatGPT or generative AI models, right? How do we take those pieces? Anybody know what Copilot is? Hear of Copilot from GitHub? Right, where they're taking and training a model to be able to give you code snippets. They're taking that same basic premise and putting it towards looking at malware. The adversaries on the other side are doing what? Doing the same exact thing so they can hide their malware, right? To be able to do it. And that's one point I like to bring up is our adversaries are doing this much faster than we are, right? Because when we get to the last couple of slides, we'll talk about our biggest hindrance, or our biggest roadblock to it is that's the ethical side, governance, laws that we have that our adversaries don't necessarily follow. Same thing here. They're going through, they're running their malware tools through the systems, building them out much faster, looking at how we're doing that, implementing it in their cycle, be able to develop malware, be able to detect malware on their side, right? So as our developers are doing things to be able to give us capabilities to do operational things and offensive capabilities, they're doing the same things on their side to try and implement it so they can do the detection of those pieces. Right. Threat intelligence. Any threat intel analysts? Is this all supply people in the room? Or is just everybody shy this morning? I swear I won't make fun if you're a threat intel analyst. It's threat intelligence. There's a lot of companies out there, right, producing a lot of threat intelligence, open source intelligence, specific pieces. Being able to pull that in and scrape it and make sense of it, right? To be able to take and aggregate trillions of reports across the globe about activity that's going on, taking in news articles, taking in chats from somebody else, going through Stack Overflow and seeing if there's a conversation about, hey, there's something wrong in my code, what's wrong with it, right? Being able to pull all that information, getting on the dark web, pulling information off the dark web to be able to aggregate all that into it and be able to give you some information. This is one of the things that we're kind of working on for like our cyber threat ChatGPT-ish thing that we're building out. Is like, how do we pull all that in, train a large language model to be able to answer the questions when I go back, and not just the most simplistic ones. Like we first started doing, we asked it, we could go in and we could go, what is the Rancor group? And it could give us back a very, very generic answer. And we tried it on Bard, ours, and OpenAI's. OpenAI wouldn't give us an answer back, and that's not because they couldn't, it's because they wouldn't go back far enough to get the information. They stopped training their model at a certain date, and the Rancor information was beyond that date. So it wasn't necessarily they didn't have it, they just hadn't trained the model on it. Bard, everybody know what Bard is? That's Google's chat bot, basically. It gave us back a 100% correct answer on who the Rancor group was, and they even got more information. Anybody want to take a guess why? Google's got a lot of threat intelligence, right? They have a lot of surface that they've been collecting over a long time, and being able to pull that information and index it and train their models on it. So ChatGPT or OpenAI may not necessarily have had that information, but because Google does, they're able to train their models, so there's see differences between models. And then ours, we only trained ours on like 6 billion parameters, and we were able to get like a very nascent answer back. It's a cyber threat group. couldn't tell us the country. It couldn't tell us what operations they did or what some of their TTPs. But we started building out and being able to do it, and it started off being like a 3-hour build, training running through it. Now we're at a 6-day build or training effort, and we're starting to get back more and more things. I will tell you, one of the things that we see in training these models and going through like large language model generation, we even had questions with it at first. That was, how does it know some of these things? Well, the first time we asked it what the rank core group is, you might want to take a guess what it gave us an answer back as? See if there's any Star Wars nerds. It told us it gave us a pop culture reference. And we spent about 2 or 3 days trying to figure out why it was telling us that it was Star Wars related, when we were like, it's cyber threat related. It's because we had trained it on the Facebook data, and in Facebook data, it had references to pop culture, and the rank core group happened to be one of those things. So we had to start seeing those pieces in it. Anybody know what that we would call that in large language models? If I ask it a question, it gives me back something that's not even relevant to what I want, or kind of close to it, but it looks like it's made up. What's that? Hallucinations. Yeah. And you'll hear a lot about hallucinations because we have to add in what guardrails. And NVIDIA's trying to answer that question with NeMo guardrails. And doing some other things. Right now, the best effort that most folks are getting is calling an API to another chat model or another large language model and being like, hey, is this a crazy question? Or is this a crazy answer, or should you be getting this answer back? So a lot of steps that go into it to try and get information back and build those pieces out. Right. Incident response. This is probably another big area that kind of ties it all in together a little bit. Being able to detect activity on a network, understanding what it's doing, and then being able to appropriately respond to that incident, right? So that an operator doesn't have to do it. If you haven't ever seen, who's ever seen an incident response? Like a network attack? A few folks. How long does it take to try and figure out what's actually going on and how to remediate it? It's annoyingly long sometimes, right? Because you're not sure what exactly it is. The intrusion detection system will be like, oh, there was a man-in-the-middle attack, and now you've got to go and try and figure it out. Who was doing the man-in-the-middle attack? Where was it coming from? What's compromised? Is it all these litany of things? Well, the AI models and the AI platforms would be able to rapidly do that for us. If we have them all tuned correctly, and they're all working in unison, and they're being protected, when something occurs and it can be flagged and prioritized, and we can train the models, be like, hey, is this an extremely high value target that this is occurring on? Execute the remediation, or at least do something to stop it, to isolate it, right? We can train those models to be able to do that, where operators would take hours, if not days, sometimes to be able to do it, if they even recognize it was happening because of the inundation of flags and incidents and everything else that's occurring, right? If they get something and they get one that might be a false positive, then it's a high priority, and they spend a day and a half trying to figure that out. And the low-level one is actually the attack that occurred, right? The lower priority one is the most important one. Then we have a problem, right? But the AI will be able to help us answer that question, get back and do the remediation. Is it easy? It's not easy at all, especially like when we start mapping some things out, when you start trying to map an action on the network to what is actually occurring to, say, a CVE or even to a KEV, right? All those other pieces, it becomes extremely difficult for us to be able to map that. Is it getting better? Every day it gets better, but it's still in a very nascent state, right? We have a tool we run, and it can tell us, hey, we think it's this activity, and here are probably 5 mitigations you can do, but you still have to spend the time to be able to go do those actual mitigations to see, this will probably do it. And then what happens after that? Anybody want to take a guess? You have to wait to see if it worked, right? And in this process, when we train a model, like one of the things that we do for our tool that we're using is we have to have a bake-in period, right? Set it on the network. It has to baseline the network. The longer we baseline it temporally, the better it gets, right? But after we do an implementation of some sort of mitigation, then we have to re-baseline the network to make sure that nothing else is occurring around that, so that it normalizes out. So that could take another day, 5 days, 6 days, 2 weeks, right? So it's a waiting game, right, with AI. Management will want what? An immediate answer, and sometimes that's not going to happen. So everybody has to understand, like, in the process of doing this, in the data science cycle, to be able to train the model and retrain the model to get back to a point of normalcy, it takes a lot of time, right? And there's a lot of waiting, a lot of sweating, right? Offensive operations. Who's in offensive cyber operations? I'm going to stop asking any type of those questions like that. This is not that audience, right? Operations planning. So this is one of the big areas we can feed information into, like a large language model or some other pieces. I'm drawing a mind blank right now, but a few years ago they did one where they took an op plan and they fed it in. It was a notional zombie attack, right? And they fed the op orders in and everything else, and then the operators could go in and be like, if there was a zombie attack in Frederick, Maryland, what should my response be? Right? And it could tell them, hey, based off of all the other information we have, we're able to do that. You can actually take these large language models and do the same thing, feed in the op plans, feed in training plans, and say, hey, show me my gaps. Right? You do the same thing with the offensive cyber operations planning. Tell it what you want, tell it where you need it to go, what actions, what outcomes you want, and then they can start planning those out and doing those things for you. Now, we talk about ethics and authorities. That's where we'll get in a little bit more deeper into some of those pieces and everything else on what we should do and what we can do, and where people's get the heebie-jeebies, right? Especially when we start talking about letting AI make decisions and do things for us, right? Mission execution, same thing. We're training out these large language models and these AI capabilities to be able to execute on once it's planned, right? So we could say, hey, go and do this. And sometimes we want that on a more lower level capabilities piece, right? If you're sitting there, I like to use Teslas. Anybody have a Tesla? One person. A couple people. All right. Nothing bad about Teslas, right? But think about what the autonomous driving vehicle in a Tesla does for us. It's supposed to assist us, right? Not just do it for us, because of why? It's doing very critical decision-making for us, right? So how much trust do you have in that critical decision-making process in that car? How much trust do you have in the mission execution phase of offensive cyber operations when you're looking at taking and doing something, right? You're attacking something. I like on our critical infrastructure side, we do a talk after a while about it and everything else. I say the easiest way to take down a city or a municipality or anything else is to go in and attack the hospital. And not take down components in the hospital, but take one thing out of the hospital, and that's expire medication. Right? If you imagine if we went to New York City and I attacked the New York City medical system and I can expire all the insulin in New York City, what would happen? It would be a mass panic. It'd be even worse than if you attacked the water system, because you can go and buy water at the store. You can go out someplace else, but you throw something like that into if we have something that's doing pieces like that, and we're not sure, and we're letting it make a decision point on its own and make that critical decision on what to attack and when to attack it, we have to make sure that we really understand what it's doing with some of the targets that it's going to be going after, and not just letting it pick its own self, right? Adversary evasion, and then we're both doing this, us and our adversaries. So implying adversarial AI to be able to detect and maneuver around us, and we're doing the same thing to be able to detect their maneuvers in cyberspace and maneuver around them, right? So it's continuously going back and forth. I know I'm going to get an answer back on this. How many of you have seen war games? Yes, right? It's the game of chess, right? Going back and forth, working through all the possibilities, letting AI figure out what the best strategy is. They're doing the same thing on the other side, on the adversary side, to get them to go back and forth and back and forth. And it's almost like a war of attrition with the AI, right? It's also not just seeing how to conduct specific cyber operations, right, or throwing offensive cyber at a particular infrastructure or some other tool. It might also be something else like attacking data for another platform, right? Poisoning the data so we can do what? Influence their artificial intelligence, right? What's the most valuable thing in the world? Information is. I think it was like 4 years ago, it surpassed the price of oil, or the value of oil. Right? The most valuable thing is information. Data. So if we can attack our adversaries' data, and they can attack ours, they can influence our AI, we can influence their AI. Activity attribution. In cyber operations, how hard is attribution of activity? Very, right? It's very hard to say that a specific event is attributable to another nation state. Because why? Other really good nation states like depending on other nation states and other people, right, and other organizations to be able to do those things. And our nation state adversaries, some are really loud, they don't care, because they can just inundate us with stuff and hide in the noise. Other ones are a little bit more sophisticated. So being able to go through and be able to do that and have the artificial intelligence help us do that, or hide our attribution of our activities, right? To be able to say, hey, if we wanted to, this is what I would do to look like this piece. And that goes back to the other piece, like malware detection, malware analysis. We could take our tools and say, if I wanted to look like a Russian APT, here's their tools. Can you craft me a tool that looks like that, right? So that I can use it to my own benefit, right? Large language models, things that they're building out like Copilot, some of those pieces. Now, I'm probably not going to answer back on this one, but have any of you done any coding with ChatGPT or Bard? One or two? Has it always come back 100% correct? No. Pretty close. I did it a few weeks ago and asked it to just do a quick script for me in Python, and it gave me back, and I was like, hey, it was almost 100%, and I found myself having a conversation with ChatGPT. I was like, hey, it was almost right, but this probably should have been an integer and not a string. And it was like, oh, I'm sorry. Here's the new code block. And it gave it back to me the way I needed it to be, right? So being able to do those things and be able to hide within the noise, be able to have the artificial intelligence develop out new tools and techniques and make it look like somebody else, almost like deep faking malware. We'll get into some examples now. Anybody have any questions so far? In the back. That's a lot to unpack in one question. So we started with an OPT model from Facebook, which is openly available. The OpenAI ChatGPT, I think 2.0 was available. They made 3.0 available, but there's probably 100 plus large language models out there to be able to train on, doing BERT and a bunch of other things out there. The amount of time it takes really depends on how much data we're pulling into it. We did something with Fleet Cyber where they were trying to do a large language model to do phishing detection. And the hardware that they had available to them, it was taking them about 18 hours to do. They came over to our lab, spent about half a day. It took just over an hour to download their data set that they wanted to train against. They went and got lunch, came back, the data was downloaded, loaded it up into the DGX, and we had a trained model in 38 minutes. Right? Now scale that out. That data, I think it was only like 10, I'd say it was like maybe 10 billion parameters. So 38 minutes, 10 billion parameters for a model that could be able to do some sort of phishing detection. Right? Now, that does not extrapolate out across or scale out across. If we wanted to train it against, say, all the emails in the DoD, right? To be able to baseline what good emails look like and be able to pull those feature sets in and be able to do it. It would take weeks to be able to do that, depending on the size of the infrastructure that you have. That's one thing too. The infrastructure is very important, and it's very costly. Anybody want to take a guess on what the base component for training a large language model? You can do it on lesser hardware, but the recommended from NVIDIA to do a large language model training on, say, a 30 billion or 60 billion parameter file, it's right about $250,000 for the GPUs. Right? If you want to rent that in AWS or Google or anything else, that's about $20,000 a month. Oracle's bringing some capabilities online, and they say it's probably going to be about $14,000 to $15,000 a month just for the GPUs, the vGPUs, to be able to do that. That doesn't include data storage, data transfers between the GPUs and the data storage, hosting of everything that comes after that. So your prices go up exponentially and crazy. And that's something like on the management side of things. It's not cheap at all. In the back. It is, so there, but it depends on how much data and what performance you're going to get back off of that. On whether or not you're actually saving money or you're expending more money going between a TPU or GPU. And I bring up NVIDIA a lot. I'm a fanboy of NVIDIA. We have a little relationship with them. But some of the things that they're doing with the GPU, CPUs, if anybody know their Grace Hopper chip or here at Grace Hopper, they've actually taken capabilities from the GPUs and now they're putting it on the CPU to compete against, AMD and Intel. It can actually do a lot of the same processing that GPU can do. And then also DPUs. Anybody know what a DPU is? Data processing unit. But when we say that, we're really talking about, in their speak, putting the operating system and the GPU processing on the NIC card. So we can move all the compute space onto the NIC card and do it at line speeds. I see the heads going. That sounds weird. So the DPU 3 that they have out right now can do 40 gig per second processing of Morpheus at full line speed. So you're doing artificial intelligence anomaly detection on the NIC at line speeds, right? And it's going to get faster. So we can do things like take these DPUs at some point and put it on undersea fiber cables at the border and do anomaly detection at those gateways on fiber at line speeds, right? It's pretty crazy stuff. Examples, large language models, you heard me talk about it quite a bit. Large language models, generative AI, those are all the things you're hearing almost every day in the news right now, right? That's consuming the discussion on artificial intelligence and what we've been talking about a lot already, right? Deep learning algorithms to take and generate, translate human language, have a conversation with humans, right? These large language models are the basis for a lot of different things, like deep fakes. We'll talk about deep fakes in a second. A bunch of other things. There are a lot of, when I said adversaries are starting to pick it up, so the big ones right now, Facebook and OpenAI and Google, all their offerings, right? They're trying their best to give humanity something we can all use to better ourselves, right? Well, immediately what happens? Bad guys in the world figure out how to use that to do bad guy things. So a group has come out with Worm GPT, right? And what it is doing, what they're selling is services online to be able to do malware, right, generation, be able to do phishing campaign generation, be able to do data poisoning with it, a lot of different things. And you can get the services on the dark web, right, and use it just like you would go in there and be like, here's my target. I want to target the 5th Special Forces Group, and I want to be able to send a phishing campaign to all of their people. And here is the website. Extract the leadership from the bio pages and send them all emails to try and get them to click on something, right? You could put that all in there and have that conversation with it. And you don't have to have a programmer or a malware analyst or a phishing campaign expert be able to do all that stuff. It will just generate it up for you and tell you, here are the emails to send, here's the infrastructure you're going to put them at, go and buy this, set this up, go to town. So we're taking the premise of taking a script kiddie who's going to download a script that somebody else has used to giving them a platform they can be like, I want to do this, and giving them back all the tools they need to be able to do it, right? A very low cost relative, right, out there. On the cost side, I'll step back. That was one of the other questions. Anybody, guys probably don't know this, but whenever you want to use ChatGPT aside from, you can do like a service agreement with them, right? You can buy like monthly credits and everything else. To be able to use some of their enterprise grade things, you get charged a per question or per instance fee. We did it just to do some guardrail testing with it, and we asked it about 20 questions. It cost us 13 cents. And you're like, oh, it's 13 cents. Imagine scaling that out to 100,000 users, asking it 100 questions a day, right? It becomes very cost prohibitive. Some of these things, though, are using infrastructure like this, and it's not costing that much to be able to use, right? There are some other financial incentives for them to be able to pull pieces in and do some other things. But deep fakes, everybody loves deep fakes, right? Oh. No, we haven't gotten that far into it.
And I was just thinking to the heuristics, I was thinking to the worm, the malware, there may be some use cases where that might actually prove some progressive performance improvements.
It definitely will. That's one of the things we struggle with in our lab is the velocity of capabilities that are coming out. And there's not a company out there that won't tell you that. The velocity of capabilities coming at AI developers right now is just as bad or just as troubling to us, and trying to get to understand. Like going back again to like on the large language model piece, that we were asking it questions, we had to go back and make sure that we were getting the right answer back because we didn't even know that we trained it to answer that question, right? And we made it also a big effort was we disconnected our DGX and our deep learning pod off of our infrastructure, so it didn't have access to the internet or anything else, because we were like, I'm not a tinfoil hat wearer, but I'm like, I don't know if I want this attached to the internet yet, because some of the things we're doing, some of the things we're feeding into it, I didn't want it learning and going out and asking a question and everything else. And that, we'll talk a little bit more about that in a second when we talk about data poisoning and stuff. Deep fakes, everybody loves deep fakes. Everybody got the app on their phone. Make a deep fake yourself singing Shark song. All right, everybody does that. The one on the bottom, did everybody see that back in, I think it was March timeframe? They did a deep fake of President Biden saying that he was going to initiate a nuclear weapon or a nuclear strike against Russia if they kept going on, right? Got a lot of people spun up pretty quickly until people realized like he's talking way too coherent in the video. And that, yeah, it's full sentences. That's not, I'm not trying to make fun of them, but there are like tells, right, that you can see. And they did the same thing with President Trump, right? The images on the top, right, using generative AI to somebody went onto it and said, hey, show me a picture of Trump resisting arrest, and generated the image and then started circulating them around, right? They can do that to a lot of folks. The big one we're seeing right now in the community is the use of deep fake voices to be able to call and manipulate the endpoint. Some of them have been so good that they'll call and it sound just like the CEO of a company, like, hey, I'm in Aruba and I need you to transfer $100,000 to this bank account because we're going to do business with this company. And don't worry about calling the CFO because I'm the CEO. Go ahead and do it. They're like, okay, whatever. Here you go. Here's $100,000. I've seen some instances, and at DEF CON this week, there were some people that were using it in real time and doing it, and pretty good. So you take somebody who's really good at social engineering and give them the capabilities of a large language model or enabled AI to be able to enhance those skills, and they get pretty pretty devious pretty quickly. I think you had a question over here.
Yes, earlier you mentioned hallucinations and having like a valid reply, but it had nothing to do with your actual search. And then you added new data to it, right? Added a new article or something
Yep.
like that. I'm real curious how, you know, how a model is going to take that new data and then look for more examples of that specific function. You know what I mean?
Yeah. So in that data, in the training of the model, there are some ways to do what they call p-tuning, like feature tuning. Like you can take OpenAI's model, and then instead of retraining the entire data, the entire model, you can feed certain points into it and be like, here's this new data point, learn this, and add these different points onto it to be able to do it. That's one way we're taking like the defensive cyber large language model we're training, and we know that some are going to want to be honed to specific AORs, and so we can take and create a baseline and then take specific information for a specific AOR and add that onto the model and then deploy that to that team that's going forward, right? So it's fine-tuning it for area-specific things. You have to go back through and you have to test to make sure that you've used it, or not used it, but just trained it, and you've basically clean that model out from any type of information that you didn't want in it, right? If it gave you back a bad answer to something,